Today we're going to look at an example of in 9.2 of a two-sample t-test. We're going to be testing the difference between two means. We're going to have two samples of data. Our first step is to read the problem and decode it. Two random samples of earnings of professional golfers were selected. One sample was taken from the Professional Golfers Association, and the other one was taken from the Ladies Professional Golfers Association. At alpha equals 0.05, is there a difference in the means? The data are in thousands of dollars, and use a p-value method. So we're going to go ahead and use our graphing calculator to do most of this problem. We'll do some of it by hand so you can see the two methods. But the first thing we need to do is take this data and enter it into our calculator so that we can get our descriptive statistics. We need X bar, we need our sample standard deviation, and we need the number of samples. So if I look at my graphing calculator, let's hope that works. I've already entered this data into my calculator. So I turn my calculator on. If I go to statistics, if I go to edit, which is option 1, you can see all of my data is there. So then I'm going to go back to statistics. I'm going to go over to calculate. I'm going to go to one variable statistics. I'm going to enter list 1 or list 2. I need to do this twice because I need to get descriptive statistics for both. So for it to say list 1, I just go second and the number 1. And then I'm going to hit enter. And enter. And here I can get my X bar. Notice I have my X bar. Then I have my SX, which is my sample standard deviation. And then I have N, which is my sample size. So I can do this again for list 2 and get all of my descriptive statistics. And when I do that, I end up getting X bar for the first sample, and I'm going to call this my first sample because it came first in the problem. I'm going to call this my second sample. So X bar for my first sample, I end up getting 5,337.5, and then for my S of X1, I end up getting 4,195.1255, and then my sample size for the first sample is 8. If I do that again for the second sample, so X bar sub 2, I end up getting 1418.33. My standard deviation for X2, I end up getting 1503.862. And then my sample size for the second group is 9. So I have my two samples of data, and I need to go ahead and go through all of the steps that we've been doing. I need to write my hypotheses, find my test statistic, find my p-value. So to write my hypotheses, it says we are testing, is there a difference in the means right here? So difference tells me my alternative is going to be not equal. So my null hypothesis, what we're doing is testing means. So I have mu1 is equal to mu2. And the alternative is that there's a difference. Simply mu1 is just not equal to mu2. We don't know if it's bigger or smaller. We just know it's not equal. So we have a two-tailed test again, just like we have all along. My next step is I need to find my test statistic. And since we have two samples of data, then our formula has to account for both of them. Now we have to figure out what distribution we're using. Since we're given sample data, then we are not given anything about population standard deviation or population variance. We just have our sample variance and our sample means. We're going to use the t distribution. So my t test statistic is going to be equal to x1 bar minus x2 bar minus mu1 minus mu2 all over the square root of s1 squared over n1 plus S2 squared over N2. Now the difference right here, mu1 minus mu2, we want that difference to be in our null hypothesis, it would be 0, right? Because I could rewrite this hypothesis. This is the same thing. This is equivalent to mu1 minus mu2 equal to 0. So this guy here, for most of the stuff we're going to do, is equal to 0. So if we go ahead and plug in the information that we have, x bar 1 is 5337.5 minus 4195.1255, and then minus 0. We want the difference, or we're assuming the difference between these two means is equal to 0. And then in the denominator, we have, let's see, we have 4195. Oops, I wrote down x1 bar is given right here, 53375. x2 bar is 1418. Sorry about that. 0.33. The standard deviation for x bar 1 is right here, 4195.1255. Now that's the standard deviation, so I need to take that number and square it, then divide it by its sample size. And then same thing with the next group, 1503.862. I need to square it. When I plugged that into my calculator, I ended up getting 2.50326. So we have our test statistic, and now we need to find our p-value. So again, we have the t distribution, so we know that it looks similar to the normal distribution. It just has fatter tails. And we have a two-tailed test, so we have some area over here and some area over here. Here is my test statistic of 2.50326. I want all of this area, so those are pretty fat tails. And let's see, this is maybe 2.50. So from the test statistic to infinity, so we're going to use the t, CDF, because we want to accumulate area in the t distribution. Our lower limit is 2.50. Our upper limit is infinity. And our degrees of freedom this time is going to be the smaller of the two sample sizes minus 1. So this sample size is 8. It's the smaller of the two. And I'm going to subtract 1, so I get 7. Now that's just approximation. This is the approximation that your book uses. Your book says, okay, for the degrees of freedom, I'm going to approximate it by taking the smaller of the two and subtracting 1. So when we follow that approximation, we end up getting 0.02037. But again, this is a two-tailed test, so we multiply by 2, so we get 0.4079. Now this p-value is smaller than our alpha. Our alpha was given to us as 0.05. So since my p-value is smaller, we're going to reject H0. We're going to reject the null, which means we have evidence to support the alternative. We have evidence to support the means of the earnings are not the same. Okay. So we can write our summary. But before we do that, I want to point out that when we calculated our degrees of freedom up here, here is our formula. So let's see if I can switch. Here's my test statistic formula. And for the degrees of freedom, we said let it be the smaller, so degrees of freedom. We're approximating with the smaller of either N1 minus 1 or N2 minus 1. The smaller sample size minus 1. This is an approximation. That's really important because if we were to use our calculator, so TI method. If we were to use our calculator, we would go to our TI calculator, and let's see if I can switch over. if I'm going to go to my TA calculator, I know I have all of my data in there because I just showed you that. We'd go to statistics, we'd go over to tests, and the type of test we're doing is a 2-sample t-test, right? We have 2 samples of data and we're using the t-distribution. So I hit enter, and it says, okay, do you want data or statistics? Well, I have data in my calculator. My data is in list 1, my data is also in list 2, and then my alternative hypothesis is not equal. It's not pooled, and then we're going to calculate. Notice that I get a p-value of 0.034, and it has a degrees of freedom of 8.59. So your calculator is using a different formula to calculate the degrees of freedom and to calculate the p-value. They're very close, but they're not the same. So if I switch back here, just to summarize that, if we use our TA calculator, we go statistics, and we go test, and 2-sample t-test, we get a p-value of 0.034, and that is very similar to what we got. We'd still make the same decision. We'd still reject our null hypothesis, but our p-values are slightly different. The one that we calculated by hand is an approximation, and the one that we calculated with the calculator is using a more precise formula. So when Connect is telling you to use the calculator, use this method. On your test or your quizzes, you need to be able to understand both methods, because I might ask you to calculate the p-value by hand, and I'll be able to tell if you did it by hand or used your calculator. If you have questions on this, feel free to email me.